bind, they can form a bridge between an MHC and a TCR without being processed. Y'all see that? They can enable a TCR right here in the blue to bind this MHC, and this super antigen shown right here is not processed. It's in its native, natural, non-degraded form. This is not a specific binding. So what happens is that when there's a super antigen present, it can activate a number of different T cells. And that can cause a disaster. Case in point, one of the best known super antigens is toxic shock syndrome toxin-1. TSST-1. Toxic shock syndrome toxin, produced by Staph aureus. Those of you who have had MedMicro know about this baby. This causes toxic shock. And what happens in toxic shock is that this antigen is secreted by the Staph aureus infection, and it can be a localized infection. Think female, feminine hygiene product. That's when we first knew about this, with a big outbreak. I'm not going to go into that story. We don't have time for that story. That was a gross story. But I remember that time too. I was in college during that. But the Staph aureus infection can be localized, secreting the toxin. The toxin goes systemic. It's a super antigen. If it comes and bridges an APC and a T cell, it's going to activate that T cell. T cells are activated when they bind an MHC antigen, right? They start dividing and they start secreting those cytokines. People go into shock when a toxin's being produced like this. They go into shock because so many T cell clones are secreting cytokines. It's called, they go into something that's called cytokine storm. That's an accepted term now, widely used. Just, it's not specific. Any T cell that comes in contact with this super antigen can be activated if there's an APC around. And so you have multiple clones of T cells dividing, secreting cytokines. The person's system is just overcome with all the cytokines that are produced. And it causes them to go into shock. Blood pressure drops. They get, their vascular system becomes more permeable. They have multiple organ failure. And that's what happens with toxic shock. Now there's other super antigens also, but that's the most famous one. Okay, does that make sense? So know what a super antigen is, and know that one example, the toxic shock syndrome toxin. And this is going to be systemic. That's what's really amazing. The infection can be localized, but it's going to be systemic. Mitogens, you need to know that term also. A mitogen is a general term. It means anything that stimulates a cell to start dividing. So these super antigens have a mitogenic effect. But there's some other things that can cause cells, especially T cells, to start dividing. One, a couple of them that I need to mention, a couple of lectins, concanavalin A and PHA, phytohemagglutinin. 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 So a couple of lectins can activate T cells to start dividing. Okay? And when they start dividing, they're going to be secreting cytokines. So you can have some adverse reactions from that. Okay? Know what a super antigen is. Okay, some other HLA genes. These are some other other things that are coded for within this complex. I don't care that we go through those right now. I just want you to know that there's several other genes that are coded for within that complex. Most of them are involved with binding to receptors and some secreted proteins and so forth. Some genes that are outside the MHC gene complex that I need to mention. One is the CD1 MHC-like molecules. And I highlighted it right here. The CD1 MHC1-like molecules on dendritic cells, mononuclear cells, and some thymocytes. These have a structure that kind of looks like two bananas on a plate, right? It looks like two bananas on a plate. Shown right here. This is looking down on this CD1 structure. And here's looking at the side. This, I think, is a mouse one, but it looks like two bananas on a plate. And it looks like an MHC. But actually, it is a bit different. The whole cleft in this CD1 is hydrophobic. It holds lipids, not peptides. It holds lipids, glycolipids, phospholipids, and lipopeptides. And the T cells, these thymocytes are immature T cells. T cells that have a CD1, we'll come back to that have a CD1 have an alpha beta TCR, but they don't normally have a CD4 or a CD8. They are negative for those markers. So they're not a T helper or a cytotoxic T cell. They're another type of T cell. Okay. So CD1, a little different. It looks like an MHC, but it holds lipids. And no, it's on DCs, MNCs. This is mononuclear cells, monocytes and macrophages, and then some thymocytes. Okay, we're ready for chapter 6, receptors. And we need to take a break. Don't worry about printing off the next lecture. Have it for next week. Because this is the part of the lecture I really didn't want to discuss. So it'll take me a while to go through it, okay? So we'll finish